Hello everyone, welcome back again. Myself, Dr. Kailash. Today we will discuss one more instrumental methods of analysis. So in this presentation, we will discuss about theory, instrumentation, and applications of flame photometry. Flame photometry is one of the methods of instrumental analysis wherein when a metallic salt solution is sprayed onto the flame, the solvent gets evaporated, leaving behind the salt residue. Whenever a metallic salt solution is sprayed onto the flame, the solvent gets evaporated, leaving behind the salt residue. This residue of the metal absorbs heat from the flame and converts them into neutral atoms. These neutral atoms of the metal gains the thermal energy of the flame and they get excited, wherein in the excited state they are unstable. Hence, they return back to the ground state with the emission of radiation of specific wavelength, which is element specific. Here, the wavelength of light emitted will tell us which element is present, and the intensity of radiation emitted tells us the concentration of the element present. This is the theory behind flame photometry. As I said, the specificity of the wavelength of light emitted makes it a qualitative aspect. See this image I have shown different elements when they are subjected to a flame test. They emit radiation of different wavelength. You can see here when the paste of different salts are hold on to the flame due to the emission of different wavelength of light by those different elements, you can see different color of flame is produced here. That is, barium emits light at 544 nanometer wavelength, strontium emits at 689 nanometer, lithium 670, etc. Like this, different elements they emit radiation at different wavelength, which makes it a qualitative aspect. Similarly, the intensity of the radiation, which depends on concentration of the element, it makes it the quantitative aspect. Though the process seems to be simple and applicable to all elements, practically few elements of group 1A and group 2A are analyzed by this particular flame photometry method. Usually it is not used for research applications, but at the undergraduate level it is used for the determination of elements like lithium, sodium, potassium, calcium, magnesium, barium, etc. Coming on to the instrumentation part of flame photometry, the components of flame photometry includes a nebulizer which converts the solution into a fine spray, then a burner, or it is also called as atomizer. It helps in evaporating the solvent, then a monochromator or filter which desired wavelength to produce desired wavelength, then a detector will be there, followed by a recorder and a display. So here you can see in a container a sample solution, so in which metal you are going to analyze, its solution will be taken in a container, and this solution will be passed through the nebulizer, and the nebulizer will be supplied with the fuel and the oxygen for burner. Okay, so when the solution is passed through the nebulizer converts it into a fine spray, and the fine spray of the solution is aspirated on the burner. So when the solution is aspirated on the burner, on the flame of the burner, the solvent gets evaporated, converting it into a metallic salt residue, which gets further converted into neutral atoms by absorbing the heat of this flame. And the neutral atoms, they gain or they absorb the thermal energy from the flame and get excited. And the unstable excited atoms, while returning back to the ground state, they emit a radiation which is specific to a specific element. The emitted radiation passes through the filter to get a desired wavelength, which passes on to a photocell detector, okay, and the photocell detector detects the wavelength of the light, and then it is sent to, the signals are sent to the recorder, where it is displayed as how much wavelength is emitted. 589 nanometer, for example, it corresponds to sodium metal. Coming on to the applications of flame photometry. So the qualitative analysis of samples by comparison of spectral emission wavelengths with that of standards. In the quantitative analysis to determine the concentration of some of the group 1A and 2A elements. For example, concentration of calcium in hard water, concentration of sodium, potassium in urine sample, the determination of concentration of calcium and other important elements in glass and ceramic materials. Okay, this is about a theory, instrumentation and applications of flame photometry. Thank you so much. Do subscribe this channel for more videos on chemistry. Thank you.